Welcome to this channel. In this video, we are going to discuss practical operational amplifier. More specifically, we will consider finite gain, finite input resistance, and non-zero output resistance. Now consider this op-amp. You know that op-amp is 3-terminal device. This is inverting terminal, non-inverting terminal, and this is the corresponding output. And always we will use this op-amp with negative feedback. So this negative feedback means, this from output will connect to the input side in inverting terminal through one resistance RF. This RF is called feedback resistance, and we can have one more resistance R1. So this kind of negative feedback circuit you will be getting in operational amplifier if you want to use op-amp as an amplifier. Now here I will consider inverting type amplifier, means input is connected to inverting terminal through this R1 and the non-inverting terminal is connected to ground, and this is the output P0. Now this operational amplifier, if it is ideal, then easily we can analyze this circuit. Inverting type amplifier, we can find out the gain B0 upon B in, and that is nothing but minus RF upon R1, that we know. But if we want to analyze this operational amplifier circuit with its practical values, means finite gain, finite input resistance, and finite or non-zero output resistance, then we need to replace this op-amp with its model. So this device will have input resistance, I will consider Ri, and this is your non-inverting terminal, this is your inverting terminal. If this potential gap, this to this gap is Vi, then this will have one gain. Here I will consider the gain is AV. AV is the open loop gain, Ri is the input resistance, and this one will have a control source. If this voltage difference is Vi between inverting and non-inverting and inverting terminal, then here we will find one voltage, that is AV times Vi, where AV is the voltage gain, and always we will connect one output resistance R0 with series with this voltage source. So it is Thevenin equivalent circuit. So this is simple model for this op-amp, where we will include the input resistance, output resistance, and voltage gain AV. Now we will connect external circuits for this inverting type amplifier. So you can see this RF is connected between input and output, means inverting terminal and output, and input is connected to this Ri, R1 rather, okay, and this end is grounded, this is also grounded, okay. So here this is the V0. Now as this end is grounded, means zero potential, and its gap is Vi, this to this gap is Vi, so obviously this potential, node potential will be minus Vi, because 0 minus Vi will be plus Vi. So this gap is Vi, means this potential, as it is zero potential, this node potential is minus Vi, okay, and this is the output V0. Remember, this voltage is AV times Vi. Now we need to analyze, we need to find out the gain V0 upon B in. This is the objective. Now how to find this thing? To find this ratio, what I will do, I will take KCL at this point first, and later I will take again KCL at this node. So first this node I will consider. So at this node, if I consider, then what will be this KCL node equations? So these node equations will be, you can see that V in is coming here, okay. So we can consider that this one, this is the incoming signal, and this is also incoming current. In this node, this is also incoming current. So these three incoming current at this node will be equals to 0. That we will consider. So this one, so this V in, this one is potential is V in, this node potential is minus Vi, so gap is V in minus Vi, and resistance is R1, so upon R1. This is the current through this resistance R1 entering to this node. Similarly, from output V0, this current will be V0 minus Vi upon this resistance Rf. Similarly, this current, okay, from 0 to this one to this side, so it will be 0 minus Vi upon Ri, and that is equals to 0. Okay. Now you can simplify it. So if you simplify this one, so what I will do, I will consider all the Vi at a place. I can take common V. This will be Vi upon R1. This is your Vi upon Rf. This is your Vi upon Ri. So there Vi I will take common. Plus this output V0 by Rf, that also I will keep on left hand side. And this thing V in upon R1, that I will take on the right hand side. So it will become now minus V in by R1. So this is one equation containing Vi and V0. Okay, so two unknown variable. So to solve these things, I need one more equation. For that, I will consider one more KCL at this node. So now I will apply a KCL further at this point. Okay, so this current equals to this current. Okay. So what I can do? So what is the current through this to this side? Okay. So this side current is, what is this? This is your 0. This node is AV into Vi. This is your V0. So AV into Vi minus V0 upon R0. This is the current from this to this side. Okay. Right. Now this from V0, it can go toward this side. Okay. So same current, because there is no branching. So whatever current is coming here, same current has to go to this one. So I'll consider that V0 minus this node potential is minus Vi upon Rf. Correct? So now we can simplify it. We can have a cross multiplications. So if I go for that cross multiplications, so what I will get? These things, AV into Rf into Vi. This is minus Rf into V0. This thing is R0 into V0. This minus plus R0 into Vi. Now again we will simplify it, because we want to express Vi in terms of V0. So what I will do, I will consider here this all Vi on this side. Okay. So this and this. So this thing I will take on right side. So this is R0. This will become minus sign, minus AV into Rf. This is a common Vi. Okay. And this one I will take on this side. So this V0 taken common. So this is minus outside R0 plus Rf. I think it is fine. It's simple manipulation. So I can express Vi in terms of V0. How? So this is, you can see that Vi now I can express. So minus R0 plus Rf in numerator. Denominator is R0 minus AV times Rf times V0. So this is your Vi in terms of V0. So this Vi I can replace here. Then we can take common V0 and we can take ratio V0 upon V in. It is that straightforward. Okay. So now let us do these things. So what we will do? So we will replace this Vi here. So you can see that this Vi is replaced here. So I will be getting V0. This V0 and this V0 will be taken common. Okay. So from this one, with this is the multiplication factors. So minus R0 plus Rf upon R0 minus AV into Rf. This factor is multiplied with this one. 1 upon R1 plus 1 upon Rf plus 1 upon Ri. Okay. And this is your 1 upon Rf. Okay, because already I have taken V naught here, and right side it is minus V in upon R1. Now it's very easy. Now we can take V naught upon V in. This is the gain, overall gain. So overall gain, to find out V naught upon V in, okay. So you can see that this is very simple. So this one is minus 1 upon R1 is outside I have taken, and this total thing I have taken inverse. Means it will be on denominator. Okay. So this is the overall expression for this overall voltage gain. Okay. Now we will take few cases to understand that our analysis is correct or not. Okay. So let us consider these things. So this is a little bit complicated, but let us try to understand whether this equation is giving you some good idea or not. So case 1, we will consider that it is nothing but ideal one. Ideal means, what is this? This R naught is 0, Ri is infinity, and Av is infinity. Okay. So if we put Av equals to infinity, so this term, so this is finite, this will become infinite. Some finite by infinite, it will become 0. So this term will become 0. So everything will become 0. This part will become 0. Can you see these things? So in the case 1, this term will vanish. Okay. Then what you will get? So you will get these things. So as this term is vanished, this is becoming 0. This is minus 1 upon R1. This is 1 upon Rf. Whole inverse means 1 upon Rf in inverse is become Rf in numerator. So numerator will become minus Rf upon R1. So this is nothing but the ideal of inverting gain, inverting type amplifier. Okay, gain is minus Rf by R1. It is known. Okay, this is for ideal op amp, inverting type amplifier gain. Okay, now case 2 we'll consider. Now we'll consider that one more thing. This is Av is finite this time. This 2 will keep as ideal, means R naught still 0, Ri is infinity. Just we are making Av is little bit finite. Then what is the expressions for this overall voltage gain? That we want to see. So here we'll keep R naught 0, Ri infinity. So this will become 0. 1 upon Ri is 0. This R naught 0, R naught 0. Okay, this 2 will be 0. So this Rf will cancel out. That I will show. So what is happening? So you can see that R naught I have taken 0. So this is Rf. This is minus Av into Rf. Okay, and this 1 upon Ri I have made 0. Okay, so this is inverse. So here you can see that this Rf will cancel out, minus minus it cancel out. Okay, so this is 1 upon Av and these things. So if you rearrange it a little bit from here, if I multiply Rf here and this denominator here, if I multiply Rf here again, okay, so what will happen here in this case? So this will be Rf by R1. This will be Rf I am multiplying here. Okay, and this will become 1. This is 1 upon Av, so this will be Av. Okay, and this is 1 upon Rf. Already Rf I have taken common, multiplied, so this will become 1. It's inverse. Inverse means it will come in denominator. So if we rewrite in far away, so what we will get? So V naught upon V in is now becoming minus Rf by R1 upon 1 plus Rf by R1 upon Av. So this is the extra factor we are getting because of Av finite. If Av is infinite, this value will become 0, we will be getting minus Rf by R1. Okay, if Av is non-zero, others are R naught is 0, Ri is infinity, we can use this formula. Okay, we can find the voltage gain. Okay, this is for case 2 when Av is finite. Now we'll extend the idea more. Now we'll consider that Ri is also finite. Now case 3, this R naught is still 0, Ri is finite and Av is finite. So only these things will come into picture, we need to keep it. Okay, so exactly similar thing, just one more term will be coming, 1 upon R1. So Rf I multiplied, so it will be Rf upon Ri kind of things. Okay, So what you will get? You will get one extra things here. This term will be there, extra terms, Rf upon Ri. Exactly similar. So you can see that if Ri is infinity, this term will vanish, it will become 0. So you will get previous case 2. Okay. Now this is the case 3. So you can see that this is the open closed loop gain for ideal 1 minus Rf by R1, and this 1 plus something, it's positive. Thus this voltage gain is further reduced. So from ideal 1, this gain is a little bit lesser. Okay. Now what I will do, I will take one example. Consider R1 equals to 1 kilo ohm and Rf equals to 2 kilo ohm, Ri equals to 10 kilo ohm, R0 equals to 10 ohm, and AV equals to 10 to the power 3. Okay, this is for practical op amp. Now for different cases I want to study, I want to see their corresponding gains. Okay, first case is ideal 1, means AV is infinite, Ri is infinity, and R0 is 0. So what is the gain? V0 upon Vin, that we know. What is the gain? That is ideal 1 is minus Rf upon R1. That is for case 1, ideal. So in this case Rf is 2k, R1 is 1k. So 2 by 1 is 2, but with negative sign, so it is minus 2. So ideal voltage gain is minus 2. Now second case we will consider. If AV is 10 to the power 3, but still Ri is infinity, R0 is 0, then how much modification we will get it? So I told you that this gain will be a little bit lesser than these things, but how much it is? With this gain 10 to the power 3. Consider that this is not very huge. It is 1000. Okay. In practice, it is practical op amp, 741 op amp, it is around 10 to the power 6. It's very high. Now intentionally I am considering 10 to the power 3. Okay. For this I want to see the effect. So for this one, this is the case 2 gain minus Rf by R1. Okay. And this is 1 plus Rf by R1 upon AV. So this factor if I include, so you can see that Rf by R1 is 2, 2 plus 1 is 3. So 3 by 10 to the power 3, and it is here minus 2. So 1 plus 3 by 10 to the power 3 means minus 2 upon 1.003. So if you do these things, you will be getting minus 1.994. You can see this value and this value, they are very close, very close. So even though we have considered one finite gain. Okay. Now further, we will consider case 3. Input resistance is also finite, 10k. So if I consider input resistance, one more term will be coming. Okay. This term is Rf by Ri. If I include this thing as well, so Rf is 2, Ri is 10. So 2 by 10 means 0.2, 0.2 will be added. So it is 3, now it is becoming 3.2, that's all. So it is further reduced, but this value you can see that minus 1.9936. It is still, it's lesser but very close. It's not reducing drastically. Okay. Now case 4 is all the variables are there. This R0 is also 10 ohm I will consider, and I want to see the effect. So there I will use these equations. So if I replace everything here, so the value we will get minus 1.99358. So you can see it is reducing very little. So very little effect on these things. So you can see that for practical op amp as well, the gain is very close to ideal 1. So this is the beauty of this one. That's how we can easily consider, you can ignore these practical values and we can find out the considering ideal 1, and you can find out the gain, and that will be very close to this practical as well. Okay. So in practice, this Ri generally in mega ohms, R0 in ohms only, and AV is 10^6 level. Okay. I hope you have got the idea. Same thing we can do for non-inverting type amplifier, but that I am not doing in this video. So I think you will be able to do these things. But if you struggle to do these things, please let me know. I will make a video on that. Okay. I hope you have enjoyed this video. So I will be discussing more videos on operation amplifier and other videos. So keep watching. Thank you very much.